For the 38th problem on the second ACT practice test, for all x in the domain of the function x plus 1 divided by the quantity x cubed minus x, this function is equivalent to what? So let's first start by just rewriting this function down below. So we have that x plus 1 is in our numerator, and we're dividing by x to the third power minus x. So just by looking at this, you want to think, what can I do to possibly simplify this? And looking at the bottom, this denominator here, you can notice that each of these terms has an x in it. So we can factor that x out. So we have that x plus 1 divided by, factoring this x out, we have x times x squared, since if you pull one x out here, you're just left with x squared. And then pulling this x away, we're just left with minus 1. And you can test this by just redistributing. So if you multiply x by x squared, you do get back x cubed. And multiplying x times negative 1, you do get back minus x. Now from here, let's focus solely on what's in parentheses. So you might recognize this as a difference of two squares, which can be factored quite quickly. So let me show you a simpler example not involving variables. So let's say that we have 36 minus 16. And what you can notice is that each of these numbers is some number squared. Since 36 is just 6 squared, and 16 is just 4 squared. And anytime you see this difference, since we're subtracting, this difference of two squares, then you can factor this like so. You have 6, and now we're writing them unsquared, minus 4 times 6 plus 4. And just to prove that this works, let's actually consider what the real values are. So 36 minus 16, we know that this is just 20. So if what I said was true, then this product of this binomial and this binomial would multiply together to give us 20. And 6 minus 4 is 2, and 6 plus 4 is 10. So we have 2 times 10, which we know is 20. So this method works, and let's generalize it using variables. So we can write, if we have a squared minus b squared, we can write this as a minus b times a plus b. And with this in mind, let's now go down to our function here and apply this principle to this x squared minus 1. So we have x plus 1 in the numerator, and then x times this x squared minus 1, but this is a difference of two squares. Since 1 you can think of is just 1 squared. So following this pattern, you first write x minus 1, and we're writing it now without the squares, and then you write x plus 1. And again, you can test this. If you use the FOIL method and remultiply these two out, you will indeed get back this. So this was useful to us because now notice we have an x plus 1 in the numerator and in the denominator. So we can cancel that out. So canceling this out, these essentially go away, and what we're left with in the numerator would be 1. And in the denominator, we have x times x minus 1. So at this point, the only thing we can do to really simplify this is to remultiply that x into x minus 1. So doing that, we have 1 divided by x times x, which is x squared, and x times negative 1, which is minus x. So this 1 divided by x squared minus x is as simple as we can make this function.